So what we have completed today, yesterday last class, preparations of glycol is completed. Next one is chemical properties of glycols. Chemical properties of glycol. What is the formula of glycol? CH2, OH, and then CH2. So it is monohydric or dihydric alcohol. What is the meaning of monohydric and what is the meaning of dihydric alcohol? If if one hydroxyl group is present on the molecule, it is going to be called as monohydric. If it is two hydroxyl groups are present in a compound, that is called as a dihydric. So this one is glycol. We are seeing that chemical properties of the glycol. I'm reacting with high reactivity metal, sodium, in the presence of 303 Kelvin, 323 Kelvin. Next one is I'm reacting with PCl5. I'm reacting with PBr3, Pi3, SOCl2, thionyl chloride. And also I'm reacting with 2 moles of HCl gas in the presence of 423 Kelvin and one more concentrated H2SO4. Wait. I'll give the time. And nitration mixture. Concentrated H2SO4 and concentrated HNO3. This mixture we can call as nitration mixture. Next one is concentration of HNO3. Dilute HNO3. Next one is concentration of H3PO4. Phosphoric acid. Next one is acetic acid. One more is HiO4 or lead acetate, CH3COO. Two times lead acetate and also it is going to be reacting with zinc chloride or anhydrous zinc chloride and one more reacting with ketone and also reacting with aldehyde and also reacting with copper in the presence of 623 Kelvin or how many degrees Celsius? So these are the chemical properties are going to be reacting with the glycol. We are saying one by one. First, it is going to be reacting with the high metal of sodium. Sodium is going to be reacting of the reactivity of sodium is high. Which of the element is going to be replaced from the glycol? Which of the element is going to be replaced by sodium in the glycol? It is going to be replacing the hydrogen. Why? Because hydrogen is less reactive than sodium. So it is going to be sodium is replaced by hydrogen. It forms CH2 and ONA, and one more is CH2ONA. The name of this one is dialkoxide or disodium alkoxide we can call. So that is the product of sodium and glycol. If it is reacting with PCl5, PCl5 with alcohol is going to be formed, sir. Which one? I already given in alcohols. It is going to be formed alkyl halides. It is going to be replacing the OH minus ion with the Cl minus ion. It forms CH2 Cl and it will form CH2 Cl. What is the name of this one molecule? 1, 2. What is the name? 1, comma 2 dichloroethane. The next one is PBr3. We can write this one is also phosphorus in the presence of bromine. If it is reacting with alcohol, again it's going to be replacing of halogen compound OH. It is CH2Br and this one is also CH2Br. Now what happened to the top? Pi3. Pi3 are phosphorus in the presence of iodine. It is going to be formed again halogenated compound CH2 iodine and this one is CH2 iodine. Now if you are observing this molecule on the adjacent carbons, there is a presence of big atoms. Iodine will be present on two adjacent carbon atoms, CH2, and this one is CH2, and this one is CH2. On the presence of two adjacent carbons, there is a presence of two iodine molecules are there. These are the big size of atoms. These are very big size atoms. There are every atom having each iodine having three lone pairs. There is a presence of three lone pairs. There is a lone pair repulsion is going to be takes place due to the presence of big size atom on the two adjacent carbon atoms is going to be very highly unstable. Due to that, it's going to be form the elimination reaction. It's going to form elimination reaction. So this bond is going to be shifted to this side. This bond is going to be moved to that side. Means iodine can be leave from here as I plus. Here, this one is going to be leave as I minus. This with this iodine is coming as with electrons. This iodine only comes out. So what will form here from these two? Minus I2. By the reacting of these two, positive and negative, it's going to form iodine molecule. It forms what will form here? There is a double bond is going to be formed in between the carbon. Alkene is going to be takes place. Alkene is going to be takes place. Glycol is going to be reacting with the PI3. Next one is SOCl2. So thionyl chloride. Thionyl chloride is going to be reacting with alcohol. What is the product is going to be formed? Acid. HCl is going to be formed. One more is SO2 gas is going to be formed. One more is main product alkyl halide. The OH is going to be replaced by Cl molecule, Cl atom. I already given in alcohols CH2, CH2. It is forms here Cl and it is forms Cl. Due to that internal conversion of nucleophilic substitution reaction is going to be formed alkyl halides with thionyl chlorides and alcohols. I already given mechanism also in alcohols. You can check that one. Next one is glycol is reacting with HCl gas in the presence of 423 Kelvin. Again, it's going to be releasing of Cl minus is going to form same product of thionyl chloride. Next one is concentrated H2SO4. It is going to be act as a dehydrating agent, means it is going to be lose or remove the water molecule from glycol. I'm taking two molecules of glycol, CH2 and OH, and this one is one OH. This one is one glycol. I'm taking one more CH2 and CH2, and this one is OH, and here also OH. If you're observing this one, there is a loss of water molecule from these two glycols. This is one water molecule, and one more is this one water molecule. It is going to form cyclic ethers. It is forms cyclic ethers. So there is a bond is going to be takes place in between oxygen and carbon, and this one is already bond is there. It forms cyclic ether CH2, CH2, and this one is CH2 and CH2. Here it will forms oxygen. Cyclic ethers are going to be takes place if concentrated H2SO4 is going to be reacting with glycol. Now, if you are taking that nitration mixture, from this nitration mixture, what is the reagent? What is the molecule is going to be comes out means there is a electrophile is going to be come out. Electrophile is nothing but NO2 plus. From this mixture, if you are taking that concentrated H2SO4 and concentrated HNO3, it's going to be releasing the NO2 plus. It is an electrophile. Now this electrophile is going to be attacking on glycol. Glycol molecule is CH2 OH, and this one is CH2 OH. An electrophile, a positive charge can be replaced only positive charge. So what is the positive charge is present in the glycol molecule? H plus. So this NO2 plus is going to be replaced H plus. It is going to be form CH2O, NO2, and one more CH2O, NO2. Next, dilute HNO3. Dilute HNO3 will act as a oxidizing agent. Oxidizing agent will be act as. So it is an oxidizing agent. It is going to be reduce that alcohol into carboxylic acid. Going to be form COOH, and one more is COOH. Alcohol is going to be reducing into carboxylic acid. Why? Because it is going to be act as a oxidizing agent. Oxidizing agent is nothing but it will oxidize others. Itself it is going to be reduction. So oxidation. Alcohol is going to be converting into carboxylic acid by oxidation. First process, first oxidation is going to be converting into aldehydes. Remove the two hydrogens, one hydrogen, one more hydrogen. Loss of hydrogen means it is going to be oxidation only now. Removal of hydrogen is also called as oxidation. If you remove two hydrogens, what will form? C double bond O, H is going to be formed. So this is called as aldehyde. If I again doing one more oxidation, what will form? There is no hydrogen is going to be removed here. It's going to be attacking of oxygen. It forms COO H. Carboxylic acids are going to be takes place if dilute HNO3 is going to be reactive with the glycol. Next one is H3PO4. Phosphoric acid. It is also like H2SO4, but it is not having that much power to reduce or release two water molecules. It can be released only one water molecule from that glycol. I am taking two molecules CH2 OH, and this one is CH2 1 OH. What is the reaction is going to be takes place in with concentrated H2SO4? Same reaction is going to be taking place, but with a loss of one water molecule. I'm taking OH, CH2, and this one is CH2. Here OH. There's going to be losing of one water molecule. It forms CH2, OH. This one is CH2, O, CH2, CH2, OH. Here also loss of water will be takes place, but only one molecule. But here two water molecules are going to be lost. Acetic acid. Acetic acid is going to be reacting with glycol. I'm taking here glycol, CH2, OH, and this one is CH2, OH. So in this process also is going to be taking place of loss of water. How it is going to be? It is an acid. It is going to release H plus. So this one is going to be act as base. Alcohols can be act as acids as well as base. It is going to be depend upon other molecule which is going to be reacting with alcohol. So it is going to be release the H plus means acid. The alcohol is going to be act as base. It's going to be release a OH minus and it's going to be loss of water. Here one water molecule is going to be lost. Here one more water molecule is going to be lost. What is the product is going to form? CH2. Here H plus. Here OH is there. Means what will present here? CH2 and CH2. These two are present. I'm writing here CH2 and CH2. Now from this, there is no element present here. Only CH2, CH2. Now if you are observing here, COOC, CH3. Right, as it is OOC CH2. This one is also OOC H3. Acetate is going to be takes place. Next, HiO4. HiO4. It is a special kind of reagent which is going to break bond between two carbons. If any molecule or compound having adjacent hydroxyl group, for example, if you are taking this one only, glycol, if you are taking, HiO4 is a special kind of oxidizing agent to use the break bond between two carbon bonds, two carbons. If you are when the carbon-carbon bond is going to be breaking means, whenever the two adjacent carbons are having OH groups, whenever two adjacent carbons having two OH groups or are one is carbonyl compound, one is OH or two carbonyl compounds also no problem. In these three cases, the HiO4 is going to break the carbon-carbon bond in between the two carbons. So how it is going to break that one? This one is going to be called as oxidizing agent. It is going to be released that we can add one OH molecule is here and one more OH molecule is here by breaking of this bond. If you are breaking this bond, it is going to be attacking off one OH and one OH. Why? Because it is going to be oxidizing agent. HiO4 or H3PO4 CH3COO twice Pb. Lead state are in the presence of HiO4. It is going to be act as oxidizing agent. It is going to break bond between two carbon atoms if it is if any compound having adjacent hydroxyl groups or one is carbonyl group or one is hydroxyl group, it is going to break the carbon-carbon bond where the hydroxyl groups are present. The carbon-carbon bond is going to break by adding of two OH molecules. What will happen here? If you are seeing that one CH2 OH, I am adding to this carbon one OH. Second molecule also same now. CH2 OH OH. 2 moles of CH2 OH and OH is going to be formed. Now if you are observing this molecule, on one carbon there is a presence of two hydroxyl groups. There is presence of two hydroxyl groups on one carbon. It is going to be highly unstable. It is highly unstable means what will happen? Again, it's going to be taking place of loss of water. Hydrogen OH minus H2O. What will form? CH double bond OH. What is the name of this one? Formaldehyde is going to be formed if HiO4 is going to be reacting with the glycol, 2 moles. HiO4 is going to be break the bond between carbon-carbon if it is having two adjacent hydroxyl groups, or one is carbonyl group, one is hydroxyl group. In other cases, it's going to be not going to be reacting with any molecule. In these three cases only, it's going to be reacting with any compound with HiO4 or lead acetate. We can take NaIO4 also. Sodium iodide oxide also we can take in the presence of HiO4. So zinc chloride, anhydrous zinc chloride, already given this reaction. What is the action of this one? It is also dehydrating agent. Dehydrating agent. CH2. So it is also dehydrating agent. Is going to be loss of water molecule. So if you are taking a glycol, one is going to be released at H plus, one more is going to be released at OH minus ion. It is going to form cyclic ethers. Next one is ketones. So if you are taking that glycol, CH2, OH, and this one is CH2, OH plus O, CH3, CH3. I am reacting glycol with ketone. Again, it's going to be losing of water molecule by taking place of loss of water. One hydrogen from this alcohol hydroxy group, one more is here from this hydroxy group, and it's going to be loss of oxygen from ketone. It forms CH2, and this one is CH2 and O. O. Here the carbon is going to be formed. So there is a loss of oxygen. This carbon is directly attached to one bond with this oxygen, one more bond with this oxygen. It is going to be form cyclic ether. Next aldehyde. Aldehyde is also same. It's going to be loss of water molecule. One is oxygen is going to be loose from aldehyde group, and two hydrogens are going to be loose from glycol. Same product, but in the place of CH3 is going to be taking place of hydrogen. O and O. This one is C hydrogen, and this one is CH3. Copper in the presence of 623 Kelvin. What is the role of this copper in the presence of 623 Kelvin? What is the role? Then what you revised yesterday? Alcohols. Dehydrogenation. Copper in the presence of 623 Kelvin is going to be lose the H2 molecule minus H2. Dehydrogenation. Loss of H2 is called as dehydrogenation process if you are doing action with copper in the presence of 623 Kelvin with any type of alcohol. Now if you are taking that glycol CH2 OH and CH2 OH, it is primary alcohols or secondary alcohol? Primary alcohol. Primary alcohol, I'm removing the hydrogen from here one hydrogen, here one hydrogen. What will form above? CHO. And below also CHO. Then what is the product? Diol. Ethane diol. Next derivative of alcohol is glycerol, OR, glycerin. Glycerol or glycerin.